Okay, we're going to look at some of the problems on the back of the review sheet for the test. All right, problem number 1. It says a stone is thrown horizontally at a speed of 10 meters per second at the top of a cliff, 78.4 meters high. So first of all, I want to draw a picture of what's happening. So this stone, make a dot for where motion begins, because that's your frame of reference, and that's important because at your frame of reference, that's where you're going to establish your sign convention that we're going to use that up and to the right is positive. Now, if it's thrown horizontally, this is my initial velocity, and then because gravity is pulling down, the path of it ends up looking like this. Now, they give us some other information in the problem. They tell us that how high this cliff is, which is y. Since I'm measuring from here down, that's negative, so it's negative 78.4. And they also tell me that the initial velocity is 10 meters per second. Now, when I write my given, whenever I'm doing projectile motion, I always separate my given into x and y. So for my x and y given, the first thing I'm always going to do is I'm always going to say that the horizontal acceleration is 0, and g is going to be negative 9.8 meters per second squared. The second thing I'm going to do is I'm going to take my initial velocity, if I can, and break it up into horizontal and vertical components. Now, my initial velocity here is all horizontal. It has no vertical components. So vi is equal to vix, which is 10, and viy is equal to 0 because it has no vertical components, all horizontal. So now my given, I'm going to write vix is equal to 10, and viy is equal to 0. The next thing I'm going to do is I'm going to say, is there anything else that's given in the problem? So the only other thing is given is y is negative 78.4. So it says, find A, how long does it take the stone to reach the bottom of the cliff? So I want to find the time. And B, how far from the base of the cliff does the stone strike the ground? So from the base of the cliff, that's this, which is x. So I want to find x. Okay. Where do I start? Well, I look at each side and I said, which side do I have 3 things on? So I have 3 things here. So the 3 things I have are, I have g, I have viy, I have y, and I want to find t. So now I'm going to say to myself, is there any equation that has these 4 variables? So the equation is y is equal to viyt plus 1/2 gt squared. Because viy is 0, that whole term disappears. So I just end up with y is equal to 1/2 gt squared. Now, because I want to solve for t, I don't just plug in my numbers. That's how we make mistakes. We rearrange the equation to solve for the unknown in terms of the known, and then we substitute and solve. So I multiply both sides by 2, I divide both sides by g, and I take the square root. So t is equal to the square root of 2y over g. So now I substitute in my values, 2 times negative 78.4 divided by negative 9.8. And we see the negative in the numerator cancels with the negative in the denominator, so I have no negative underneath the radical. Because if I did, there would be a problem. Now, it comes out to be 4 seconds, but one of the great things about physics is I always have a foolproof way to check my work, and that's by carrying my units through and canceling them. So let me go ahead and do that. Underneath the radical over here, I have meter in the numerator divided by a meter per second squared. Okay? So what that is that's a meter divided by a meter per second squared, which is a meter times a second squared over a meter. So this meter cancels with that. Underneath the radical, I have second squared. When I take the square root of the number, I also have to take the square root of the unit, so my unit ends up being a second, which is the correct unit for time. Remember, whatever mathematical function you do to the number, you do the same thing to the unit. So that's, now I see I didn't make a mistake. All right, part B said, how far from the base of the cliff does the stone strike the ground? So we want to find x. So when I'm finding something like x, I can only use the stuff on the x side. So I know ax is 0. I know vix is 10. I want to find x, but I just found the time. Now remember, time is scalar. So once I found the time here was 4 seconds, the time is also 4 seconds on the left side because time is scalar, so it's horizontal and vertical. So here's my variable. So I'm actually going to use the same equation. X is equal to VIXT plus 1/2 AXT squared. AX is always 0, so this disappears. So here's my equation. Remember, we don't learn and memorize certain equations and say, oh, these are just for projectile motion in this situation or that. That's not learning. That's called memorization, and you'll never understand it. What we do is we use the same equations we used in the last chapter, and we just remember that for projectiles, because there's no horizontal force pushing on it, that the horizontal acceleration is always 0. So we just make it disappear after we write down our basic equation. Okay? So now we substitute in our values. VIX is 10 times the time, which is 4. And I can do that in my head. 10 times 4 is equal to 40 meters. And that's it. So we did a lot of these problems. So you should have no problem doing something like this. Okay? Because we did a lot of practice of these. All right, next we're going to look at number 8 from the review sheet. Okay, number 8, it says a projectile is fired at an angle of 37 degrees with the horizontal. So now I'm going to draw my picture. Here's VI. Goes like this. And they give me the initial velocity. This angle here is 37 degrees. If the initial velocity is, what's the horizontal displacement? So I want to find x, which is also called the range. So again, the first thing I'm going to do after I drew my once happening picture is I'm going to write my givens. So in my given, I'm going to separate, I'm going to do my x and my y given. And AX is 0, and G is equal to negative 9.8 meters per second squared. Now, I want to next do VIX and VIY. Now, I'm given VI, but I'm going to do it to the side. So here's VI. And I want to find the horizontal and vertical components. The more you write down on paper, the less likely you are to make a mistake. So this is VIX, and this is VIY. And this angle here is 37. Do I use sine? Do I use cosine? What do I do? If you're not sure what to do, just write down the first thing that pops in your head. So the first thing that pops in my head is sine. So I'm going to write sine of theta is opposite over hypotenuse. So sine of 37 degrees, what's opposite? VIY over the hypotenuse, which is 1.00 times 10 to the 3. So now VIY is equal to 1.00 times 10 to the 3 times the sine of 37 degrees. So now I'm going to take the calculators that we're going to be using on the test. And the way I put this in correctly is I press 37 sine times 1 EE3 equals, and it says 601.8. So I'm just going to round that to 602. Okay, then I'm going to find VIX. So VIX is going to be adjacent to the given angle, so it's going to be 1.00 times 10 to the 3 times the cosine of 37 degrees, and that comes out to be 799 meters per second. So now I'm going to substitute these in here. And the last thing I'm going to do is I have to look at my problem and say, is there anything else that I need or that I have? And I'm looking, I don't see any other numbers. But what I do know is from where I start here to where I end up here, the vertical, this is vertical, my vertical displacement is 0. because remember, displacement is from where you start to where you end up. So vertically, I'm on the ground, and I end up on the ground. So the last thing I'm going to have in my given is y is 0. So now I have three things. Okay? Now, if I want to find x, the equation is x is vixt plus 1/2 axt squared, and this is 0. The problem with this is I don't know the time, right? So I have to find the time first if I want to use this equation. So I could find the time, and I could say y is equal to viyt plus 1/2 gt squared. Now remember, viy is not 0. So when I do this, I have 0 as 602t plus 1/2 negative 9.8t squared. The problem is I have a t and a t squared. Because this is not math class, what I can do is I can factor out a t and just solve for the positive value of t. So 0 is equal to 602t minus 4.9t squared. Factoring out a t, 0 is equal to 602 minus 4.9t. So t is equal to 602 divided by 4.9. So t comes out to be 123 seconds. Once I do that, what I can then do is go back to this equation here and say x is equal to vixt, which would be 799 times 123 seconds, and it comes out to be 98277. And because it's a big number, sometimes we just express it in kilometers, but you don't have to. Okay, you can leave it in meters. Now, is this the only way to do this problem? No. So let me just show you another way to do this same problem, and you're going to get the same answer. Okay? So another way to do this problem is when I look at my projectile, remember, this is vi. The velocity all along this goes along. So this, I'm just drawing in here, vf. Now, if I find the horizontal and vertical components, remember, this is vix, this is viy, this is vfy, and this is vfx. Now, remember, the horizontal velocity never changes. So vix is equal to vfx. That never changes, and I think I showed you that before. If we use one of the equations, we can prove that. But what does that have to do with this problem? Because we have several equations, and you don't always have to keep using these. Let's say we wanted to use another equation. So here's an equation, vfy is equal to viy plus gt. So vfy is equal and opposite to viy. See how this one goes up and this one goes down? So if I rearrange this equation to solve for time, time is equal to vfy minus viy over g. So that becomes negative 602 minus 602, because vi is positive 602 over negative 9.8. So when I do all that, I get the same answer for the time, and then I can substitute in this equation. Which way should you do it? You do it the best way you understand it. The only reason I usually don't do it this way is most people make a mistake, and they forget to make this one negative. So if you don't make this one negative, so if this one's positive, or sometimes they forget that there's a negative sign there, so they always make a silly mistake with the sign. So that's why I don't always do it this way, because you have a greater chance to make a mistake. But you do it the way that you understand it. The thing about physics is a lot of times there's always going to be more than one way to work a problem. Okay? All right, now we're going to do number 12. So number 12, it says a wind with a velocity of 40 kilometers per hour blows at 60 degrees. So all I'm doing is drawing my vector. This is 40 kilometers per hour. It doesn't tell me, like, when they just say 60 degrees, that's usually from the positive x-axis. So now, when we look at this, the question says, so this is assuming that this is northeast, which maybe it wasn't clear, and so it says, what's the north component of the wind's velocity and what's the east component? So we need to know north, south, east, and west. So they want to basically find the horizontal and vertical components. So this is where I start. This is where I end up. So this is going to be my horizontal component, which I'll call Vx. From the head of this vector to the tail of the other, this is Vy. So now to find what these are, sine, cosine, tangent, I'll just write my sine out. Sine of theta is opposite over hypotenuse. So sine of 60 is opposite, which is v sub y, over the hypotenuse, which is 40. So Vy is equal to 40 times the sine of 60. So again, on my calculator, I press 60 sine times 40 equals, and it comes out to be 34.64, so this is 35 kilometers per hour. Now this v sub y, this is the north component. So that's part A. And then for part B, cosine of theta is adjacent over hypotenuse. So cosine of 60 is adjacent v sub x over the hypotenuse, which is 40. So v sub x is equal to 40 times the cosine of 60 degrees. So again, I do the same thing on my calculator, and I press 60 cosine times 40, and that comes out to be 20. So v sub x is equal to 20 kilometers per hour, and that's it. Now, some of the other problems that we did for homework, there was one on the back of the review sheet where you had several ones like this, and you had to be able to add them up and then find the resultant. So remember, we did a little chart with the x's and the y's. We added up all the resultants. So this is just a little part of like a problem like that, which, you know, of course, you need to know how to do all that stuff. Okay? And that's it.